In modern manufacturing, welding distortion and residual stresses are among the biggest challenges faced by production team. It often requires accurate representation of geometric features, weld passes, and temperature-dependent material properties. These issues leads to dimensional inaccuracies, assembly problems, and most often rework. It also increases the production cost. In today's competitive industrial environment, the traditional trial and error welding approaches are no longer sustainable. So, a query arises among us. Is it possible to do welding simulation virtually? Definitely yes. In this video, we are going to explore how Abaqus AWI makes it possible. Abaqus AWI or Abaqus Welding Interface is a specialized simulation plugin developed for performing welding simulation. It integrated seamlessly with Abaqus Standard and Explicit as a plugin environment with industry-leading solver capabilities. AWI enables engineers to simulate complex welding processes efficiently and accurately. It transforms welding simulation from a complex scripting task into structured, guided workflow by automating most of the time-consuming tasks associated with building a weld model. Industries use Abaqus AWI to predict welding distortion, residual stresses, and temperature evolution before physical production begins. This enables optimization of welding sequences, heat input, and fixture strategies at an earlier stage. AWI is widely adapted across automotive, heavy engineering, aerospace, shipbuilding, and railway industries. Let's look into the Abaqus welding workflow. The AWI workflow starts by importing CAD or finite element model. Next, we define the materials. This includes both the base material and weld material. Each material needs a melt temperature and a cutoff temperature. After that, we move on to the part selection. Here, we choose the parts that will contain welds and the base material region. We then assign the mesh where we select the thermal element type and define the structural element type. Once the mesh is set, we create the welds by defining weld beads. Every region in the model must be assigned either to the base material or to a weld. Before moving on next, we set default controls including time incrementation, gold arc heat source parameters, film condition, and radiation loads. We then create welding steps, assign weld beads to each step, and define weld passes and time incrementation. For each weld bead, we define the weld pass details such as torch movement, heat source parameters, and torch orientation. Finally, a coupled thermal mechanical simulation is performed to predict temperature, stress, and distortion. While the structural model may need additional loads or boundary conditions added outside of AWI. AWI automatically manages element activation and welding sequencing, significantly reducing modeling effort while improving accuracy. And that's the complete workflow in a nutshell. The organizational impact of Abaqus AWI is significant. It improves the welding quality, decreases the production risk by optimizing overall manufacturing cost. AWI enables data-driven decisions in welding process design. To summarize, Abaqus AWI bridges the gap between design, simulation, and manufacturing. It replaces trial and error welding with predictive simulation-driven engineering. Abaqus AWI is a powerful solution for industries aiming to improve welding quality, reduce distortion, and optimize production. Reach out to us to know more. Thank you.